really well on this. But I've identified a few questions that it looks like there were some issues on. What I'm going to do here is I'm going to ask for the thumbs up, thumbs down. And here's my thinking on this. I want to get to the lab and just answer questions, kind of let you work on finishing up, the parts of the review that you don't have done yet. I'll put practice tests up so you can go through those tonight also if you want to. But if there are lots of questions, here's my thinking, lots of questions on one of these, it'd be a lot quicker for all of us if we just did it right now in class so I could free myself up for other questions in the lab. So let's get to it here. This one. Yes, thumbs up meaning you want to take a look at it?
Yeah.
Or no? Okay, so hands up if this is one you want to take a look at. Okay, put your hands up high if this is one you kind of want to see. And if it's like 6 or less, we'll just do it down. 1, 2, 3, 4. Okay, that's enough that we'll go through this one. Okay, so real quick, I want to make this quick. So think what we're doing with this now. We've got this piecewise function graphed up here, and we want to essentially write the function that goes with the graph, right? So there's 4 parts to this. We want to first of all pick which of these 2 forms fits. The only difference being how they treat the endpoints. That's it. Okay. So first things first. Actually, let's start with C. What is the breaking point? -3. Okay, good. So here's our breaking point right there. Right. So that's at x equals -3. So then now look with the SBAT -3. You get the idea. So you get the look at what these mean. F of x is the piecewise function. It's either going to be this one on the left or this one on the right. In either case, g of x is defined when x is less than c. Either less than or equal to c or less than c. You got to pick which is the right one. But less than means left of, right? So what that's saying is that g of x is going to be the left function, and h of x is the one that's defined when x is greater than c, or greater than or equal to, whichever one fits this situation. But g of x is going to be the left, and h of x is going to be the right, okay? Well, first of all, which endpoint situation fits? Which one gets to keep the endpoint, the left function or the right? Yeah, so h of x gets to keep it, doesn't it? And so this is going to be j. That's the one that we need. Sorry, that's the one that we need because it includes, see, look, it includes the equal sign with h. Got it? Okay, so that's j. And then the rest of this really is just kind of, we're just seeing what the equations of the lines are. So it's the same stuff that you did in the earlier questions where they're giving you, for example, 2 points. You've got to come up with the equation of the line, right? This one's easy to do. H of x is really simple because we can see that the y-intercept is right there. What's the y-intercept? 3. All we need is a slope, and then we just write it in mx plus b form. So I've got 2 points. I always go left to right. So my slope is -1 over +3. Agreed? Yeah. So then isn't g of x just equal to -1/3 x plus 3?
Yes.
Okay. So if I want to find, no, that's h of x. Sorry, h of x. Sorry. If I want to find g of x, unfortunately that one doesn't go through the y-axis, so I can't see b directly, but I can find it. It's no big deal. I know the slope of this guy is what? Well, it looks like I'm rising by -2, running by +3. So m equals -2/3. I've got a couple of points that it goes through. If I just plug in the values of x and y for a solution, I could easily solve for b. Well, let's pick this one, okay, because that's an easy point. What are the coordinates of that point?
Can't you just go down to?
Well, I mean, so good. So you're saying, could you just extend this? You could. You could just extend this, right? But what if you couldn't? So you could in this case, but how would you deal with it if you couldn't? Because you might get one where you can't.
Put in a coordinate point.
Okay, so we're going to put in the x and y coordinates of a solution. My point is just that this is probably an easier point because it has a 0 in the coordinates, right? Aren't these coordinates -6, 0?
Yeah.
Right, so we can plug in then into y equals mx plus b. We could plug in -2/3 for x, or for m, sorry, for x we could plug in -6. for y, we would plug in 0, and then we're trying to solve for b, right? Okay, so negative 2/3 times negative 6/1, negative times negative is positive, right? And so I get 4. 0 equals 4 plus b, so what's b? Negative 4. And so then we get the other side, g of x equals negative 2/3 x minus 4. Right? Okay, that was quick, but does that help fill in the blanks? Okay. This one, yes or no? Yeah? Okay. Okay, so these, now let's talk about these. If I'm given a linear inequality in two variables, the graph, and I've got to write the inequality for this. Very simple. All we're going to do first of all is we got to find the equation of the boundary line. Because remember that an inequality consists of the boundary line and then the shaded region. If I find the boundary line, it's easy, isn't it? The boundary line we can just see by inspection. We can see the y-intercept, we can count the slope using a slope triangle. So what do we get? Looks like we get, what's the slope here? Negative 3/2. Everybody agree? So negative 3/2 x plus, I think it's actually 3, okay, plus 3. Okay, so that's the equation, but we don't want the equation. We want the inequality, right? So we need to replace this equal sign with the appropriate inequality. So we've essentially got to fill in the blanks here. We know it's going to look like this. Y something. Negative 3/2 x plus 3. We got to fill in the blank. There's two ways we can do that. The shortcut is, remember that if the inequality is written in slope-intercept form, it's really simple. Greater than means it's shaded above, less than means it's shaded below the line. So this is obviously less than. Okay, but what if we didn't remember that, or it wasn't written in slope-intercept form? We can always use a test point. So let's pick a point that is in the shaded region.
0, 0.
0, 0 would be an easy one, right? So 0, 0.
Can you do that even if it wasn't in the shaded region and then you just do opposite?
You could, sure you could, absolutely. So 0, 0 should work. That's a solution, right? So now think how we could do this now. If I were to plug in 0, 0, whatever result we got here would be the correct one. Agreed?
Yeah.
Because that's got to make it work. It's in the shaded region. It's a solution. So if I put 0 in for x and 0 in for y, I'm going to get 0 on the left. On the right, aren't I just going to get 3? Because that's going to be 0. Right? Everybody ever see what I'm doing?
Yeah.
Okay. And so then, which inequality sign would we fill in there? It's got to be a less than, right? So if the point 0, 0 requires a less than sign, and that's a solution, the answer has to be less than, doesn't it?
Yeah.
Okay. And right, oh good point. And because it's dashed, we would not include an equal sign. Good. Solid would be if the boundary line were included, if it were a solid boundary line. We'd put the equal sign also. Okay, good? Okay? Okay, I'm almost thinking these I'd rather do down there. I mean, these are coming up with the equations of the lines. I think most people are pretty good with that. I would say, same thing with that. I would say that maybe the last two, I'll let you decide. No? Okay. This one we could probably do down there, but I bet you this one, oh, hang on. That one would probably be okay with you.
Choose the graph.
Yeah, how about that one?
Yes.
No, I don't know how to do that.
Okay, so let's look at that one.
That one's on the calculator.
It's on the calculator, exactly. Okay, so these are the ones, you tell me if this is enough, and if not, we'll keep going. This is the one where, remember, our trick on a graphing calculator, and this is just general. I mean, I'm teaching you how to do this, but this will apply all through this year and next year and forever. When you want to find solutions essentially to an intersection, that's what we're doing. We'll come to think of this as an intersection of curves. If I want to find out where this f of x function has this y value, right? So it's not like I'm just evaluating. That would be easy. If I just wanted to know what's f of 4, then I just plug 4 in and get an answer. That's easy. That's not what this is saying. This is saying, what's the value of x that gives me a y value of -8, right? And so we're gonna graph the function, we're gonna graph a horizontal line at y equals -8 and look for the intersections. To graph a piecewise function though, that's a little weird and tricky. The way we do that, remember, is we're going to put a set of parentheses around the function, the first piece. Next to that, we'll put a set of parentheses around its domain, right?
And then you add it to the other one.
And then I add it to the other one. And then I'm just gonna add that to a set of parentheses around the second piece, next to another set of parentheses around its domain. Right? Does that make
Yeah.
sense?
And then the second line.
Does that make, and then y2 I would just make -8, exactly.
Oh.
And I intersect.
Wait, why is that one?
Say it again,
Why -8?
because that's what it says right there.
Do you have to put a comma between it?
No, up here you put a plus sign.
Oh,
You're actually adding the first piece. What it's telling the calculator to do is graph that function on that domain plus that function on that domain.
Yeah.
okay. Are you gonna do this?
How many people want me to do this here? Because raise your hand if you want to actually go through one of these. Okay, let's do it. Let's do it. Yeah. So if I go up here, then I'll go in parentheses. I'll make this real quick. In parentheses, I'll do fraction template 1/8 x squared minus, I'll just make that a 0.5. 0.5x, a little easier. 0.5x minus 7/2 is 3.5. So everybody agree that's the first piece?
Yeah.
Okay, in parentheses next to that,
Couldn't you just enter them as fractions? Why are you
I could, but I'm just trying to save time.
Oh,
Yeah, that's
but
it. You could, you probably should, but I'm just saving time, because they're terminating decimals. Okay, so next to that, I'll put the domain x is less than, remember where we find that, it's on the test menu, so second test, it's number 5, less than, x is less than 4. Okay, and if I were to graph that, if I just hit zoom 6, look what we get. It stops right there. It just graphs the left piece, right? And then I have that other line. The other line's wrong. We'll change it though. So if I go back to y equals, now I got to add the second piece. Okay, so then I go plus. In parentheses, now I'm going to do this guy, right? So I go -17/8. I'm just going to make it a decimal to make it quick. That's -2.125. So okay, that's 17/8 x plus 9. Oh no, that's a pretty standard one. So next to that, we'll just do x. X is greater than or equal to 4. So second test 4 greater than or equal to 4. Okay, got it?
Yeah.
And then we'll go down and make that a -8, exactly. -8. And then we'll just go zoom 6, how about?
Why?
Oh,
Just to kind of reset the screen,
Okay.
okay?
Ooh, fancy.
And so we lucked out. This one only has one solution, but it might have had more, right?
Yeah.
And if it has more, we just separate them with commas. So I only have to find one, so I just go second, calc, intersect.
Wait, how do you know you have to?
Well, because I can see on the graph it only intersected once. It missed the parabola completely, okay? So second calc 5. Okay, remember this? Listen, oh, hey, I want to get out of here. Pay attention. Look up here. So now it asks first curve and second curve. Just skip it. Enter, enter. Enter, enter, and then I got to make a guess. Now I got to scoot over next to this one, or I won't know what to do. Or I could enter an x value. It goes a lot faster on yours than it does on this one. Come on, little guy. Okay, so that's probably close enough. Yeah, and then it puts it right there, and it tells me it's at 8. So 8 is the answer. X equals 8. Okay?
But do
Got
we
it?
need 2?
No,
But there could be. In this case, there aren't. But what if that parabola had dipped down there? There might have even been 3.
Why aren't there 2?
Why aren't there 2?
Because it doesn't
Because
intersect the line.
look at the horizontal line down here only intersects the right piece. It doesn't intersect the left piece at all.
I gotcha.
See what I'm saying?
Yeah. Doesn't
Okay.
matter if there is two. Doesn't matter which way you enter.
Nope, doesn't make any difference. Just put a comma between them though.
Okay.
Down we go.
Yeah, let's go.